The Artemis II Mission, an Analysis, by Reverend Thomas Perez. Before I begin my analysis, I am going to share the following 4 videos for your perusal. The videos are in reference to the Apollo missions and the Artemis missions, in particular the Orion spacecraft, and the assertion that humans have never gone beyond the Van Allen radiation belts or to the moon. The first video features an interview with astronaut Alan Bean regarding his reported journey through the Van Allen radiation belts. The second presents astronaut Don Pettit, who states that the technology required for lunar travel no longer exists because NASA destroyed it. The third video is a presentation by NASA engineer Kelly Smith on the Artemis, specifically the Orion spacecraft, and the challenges of sending astronauts through the radiation belts, which he claims has not been accomplished before. The fourth video includes astronaut Gregory Reed Wiseman stating that humanity has never traveled to the moon. So, without further ado, let us view and listen to the videotapes.
You couldn't hear it in the vacuum of space.
Any ill effects from the Van Allen radiation belts?
No. Now, I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did.
Beginning at an altitude of 1,000 miles and extending an additional 25,000 miles, lay lethal bands of radiation called the Van Allen radiation belts. Every space mission in history with humans on board, from both the United States and Soviet Union, from the first in 1961 to the present, has been well below this deadly radiation field. Mercury, Gemini, Soyuz, Skylab, the Space Shuttle, all maintained altitudes well below 1,000 miles. All except Apollo.
I don't know the distance to the Van Allen radiation belt, and if we did, it wasn't a problem. If we were going to encounter it, then we would have had to build the spacecraft and the spacesuit to not give humans a problem. You don't just build something and hope it works. You study to see what the threats are, the environment is, and then you say, how thick do I have to make the metal on the spacecraft so that going through this kind of radiation or these kind of meteoroids, it won't get hurt. And then we build it that way.
The belts are 1,000 miles to 25,000 miles above the Earth.
Then we went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
In 1998, the Space Shuttle flew to an altitude of 350 miles, one of its highest altitudes ever, hundreds of miles below the beginning of a field of radiation that was so severe that the astronauts inside of their shielded spacecraft and inside of their shielded spacesuits saw flashes of light with their eyes shut that they described as shooting stars, due to radiation penetrating first the shuttle's shielding, then their spacesuit shielding, then their skulls, and finally the retinas of their closed eyes. As a result, CNN issued the following report noting NASA's unpredicted surprise.
The radiation belt surrounding Earth may be more dangerous for spacewalking astronauts than previously believed. Scientists say the phenomena known as the Van Allen belts can spawn killer electrons when the Earth's magnetic field changes. These electrons that are being studied could have an important effect not only on satellites, which has happened in the past, but could also affect the astronauts by creating large doses of radiation that could influence their health. The electrons can penetrate through various materials, including spacesuits, and can pass through, in fact, the walls of the space station, and can create high charges deep inside of these objects.
No strange occurrences?
Nothing like that.
The space shuttle...
Go ahead.
The space shuttle went to 365 miles a few years ago because I worked in news. I saw CNN. They said that the radiation belts surrounding Earth are more dangerous than previously believed because the astronauts saw shooting stars with their eyes closed just when they got within 600.
Radiation belt. We saw shooting stars, but they're not shooting stars with your eyes closed, although they look like it. If you're out in space beyond the Van Allen belt, and probably within the Van Allen belt, and close your eyes, and just pay attention. You don't notice it unless you pay attention. Then all of a sudden you'll see a little flash like a shooting star, except it's like that. There goes one this way. Then one just blossoms. And then not that fast. Maybe you wait 3 minutes or 2 minutes and one goes whoosh. Then you see them whistling by. Not on our mission, by the way, they hadn't been discovered yet. Then you see them whistling by. Not on our mission, by the way, they hadn't been discovered yet. Then you see them whistling by. Not on our mission, by the way, they hadn't been discovered yet. I saw them one day.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before, to an asteroid or even onto Mars. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right: fly it in space. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. We must solve these challenges before we send people through this region of space. For this flight, it's time to head home.
This is the first time we're going to send humans to the moon, and we're going to have humans in low Earth orbit. That is awesome. Like, we should, as humanity, we should take a brief moment to go, that's awesome.
According to the Alan Bean interview, the crew of Apollo 12, which launched on November 14, 1969, passed through the Van Allen radiation belts. The same applies to all Apollo missions that reportedly traversed the belts, beginning with Apollo 8 in December 1968 and continuing with subsequent missions between 1969 and 1972, specifically Apollo 10, 11, 12, 14, 15, 16, and 17, with the exception of Apollo 7 and 9. In a more recent interview, Don Pettit stated that the technology required to leave low Earth orbit and land on the moon was destroyed. This assertion raises significant questions regarding the rationale for eliminating technology widely regarded as one of humanity's greatest achievements. Kelly Smith, by virtue of what he said, challenged the accounts of previous Apollo missions regarding passage through the Van Allen radiation belts, stating that such a feat had not been accomplished before and that new technology was being developed for this purpose as part of the Artemis program, specifically with the Orion spacecraft. In a subsequent public assembly interview, astronaut Gregory Reed Wiseman supported Smith's assertion by stating, "This is the first time we're going to send humans to the moon." Why the apparent discrepancies and contradictions? There are many discrepancies and contradictions like this between astronauts, engineers, and NASA personnel throughout its existence since July 29, 1958. But for the sake of this short video, we are only going to cover aspects pertaining to the Artemis program, in particular, its launch on April 1st, 2026. During that launch, for astronauts, Christina Koch, Victor Glover, Gregory Reed Wiseman, and Jeremy Hansen supposedly left low Earth orbit and traversed through and beyond the Van Allen radiation belts and orbited around the entire moon. According to the narrative, during their journey from Earth to the moon and back, they were able to take pictures of the entire Earth as seen from space. And with that, they were also able to take some pictures of the moon's lunar surface from a distance of 4,067 miles. That's 6,545 kilometers. In addition, the narrative also states that this is the closest approach they came towards the lunar surface, as the crew swung around the far side of the moon for the first time in over 50 years. However, discrepancies, inconsistencies, and contradictions persist. The following photos were checked for validation through various AI detector applications and were found to be fakes. This also includes NASA's new blue marble Earth photo. Moreover, the resulting application score percentages were between 47% and 100%, with most of them presenting a score of a 97% fakery rate. Why are the photographs coming back with a consistent high percentage rate as being altered, tampered with, or AI generated? Before we answer that question, let us take a look at some of these photographs first. Each photo was examined into 3 to 5 different AI detector applications for confirmation. Notation: every time you see a percentage score, like in some cases 47% and so forth, that means the image or video was edited by a human, as in 47% human, while the other 53% score means that the final product is artificial. You can look this fact up for yourself. Let us take a look at the following photographs, starting with NASA's new blue marble image. In order to confirm my findings, I took a screenshot picture of an animated cartoon in order to validate its authenticity and 2 live pictures of my cat and one of my computer desk. All 3 of these images were found to be what they are: a cartoon image and 3 real images. See the following 6 images. Following the examination of selected photographs, attention now turns to the live video streams provided by NASA. The authenticity of these videos, whether genuine or AI-generated, warrants critical evaluation. The following 4 videos, however, and notwithstanding, were found to be AI-generated.
You're seeing this? Earth looks incredible from up here. That green glow over Norway is beautiful. I've never seen it spread this wide.
As you can see, all videos presented were found to be AI-generated. Let us now turn our attention to the photographs taken from the Artemis II Orion spacecraft of the United States flags left on the Moon during NASA's Apollo mission programs. Are those photographs fake? Were those photographs tampered with? Are those photographs AI-generated? See the following photograph. Flashback. How close did the Artemis II Orion spacecraft get to the surface of the Moon? As previously stated, the Orion orbited the Moon from a distance of 4,067 miles, that's 6,545 kilometers, above the lunar surface. According to Google search, one cannot see or photograph the flags from that distance. Moreover, according to the same Google search, it is stated that in order to photograph the flags, a ship would literally have to be much closer, at least typically in a lower 31-mile orbit above the lunar surface. See confirmation of this in the next slide. Hence, we now know that the preceding photograph is literally impossible. However, some of you are probably thinking, granted, but what about the photos of the Apollo 11 and 12 module landing sites on the lunar surface, as taken by India's Chandrayaan-2 spacecraft on April 2nd and 5th, 2021 by the Orbiter high-resolution camera from an altitude of 100 kilometers, 62 miles above the lunar surface? See the following image. According to the narrative, the Chandrayaan-2 came within 62 miles above the lunar surface. However, according to another Google search, even at that distance, we still cannot see any American lunar modules or any other equipment from an orbiting spacecraft. But astronauts and orbiters, according to the narrative, can see them with powerful optics like India's Orbiter high-resolution camera and NASA's Lunar Reconnaissance Orbiter camera. See the following 2 slides. According to the narrative, the Chandrayaan-2 camera provides a high resolution of a 0.32 meter per pixel. Furthermore, a camera with a high resolution rate of a 0.32 pixel can indeed easily distinguish cars, trucks, vans, and different types of vehicles from 62 miles above. But what of NASA's Lunar Reconnaissance Orbiter? According to NASA, Their Lunar Reconnaissance Orbiter photographed all Apollo landings from an altitude of 20 to 50 kilometers. That's 12 to 31 miles above the lunar surface, using a high-resolution pixel of 0.5 meters when operating from its nominal 50 kilometers, 31 miles, and a 0.4 to 0.2, depending on the latitude and time of year, due to its elliptical orbit, changing its resolution. These alleged distances should provide us with crystal clear images, but they do not. See the following images. High-resolution imaging, such as that provided by the Lunar Reconnaissance Orbiter camera with rates of 0.2, 0.4, and 0.5 meters per pixel, generally surpasses the capabilities of the Orbiter high-resolution camera from Chandrayaan-2, which achieves 0.32 meters per pixel. Despite these advanced imaging technologies, none have produced crystal-clear images of lunar modules. Numerous images captured by the Lunar Reconnaissance Orbiter reveal the modules left by the Apollo 11, 12, 14, 15, 16, and 17 missions, yet these modules remain indistinct. Even with corroborating images from 4 other countries documenting the Apollo 11 module site, a clear and definitive image remains unavailable. Notation: casting shadows, as shown from each country respectively, does not align relative to where the sun's horizon is. See the following images. But for our intent and purposes, we will only look at the Lunar Reconnaissance Orbiter camera. The LRO features 2 types of cameras with different pixel resolutions and data rates. The first is a spatial resolution, pixel scale. This is divided into 2 camera types. The first type is the narrow-angle camera. The narrow-angle camera provides high-resolution images with a pixel scale of 0.5 meters, with an image width of 5,064 pixels per camera. That is 2 cameras used together, providing a swath of over 10,000 pixels. The swath coverage is 5 kilometers or 3.1 miles. That's 1.6 feet per pixel. Its format are line-scan imagers that take long, thin images, often up to 52,224 lines long. The second camera type is the wide-angle camera. The wide-angle camera provides lower-resolution multispectral images with a resolution of 100 meters per pixel for visible light and 400 meters per pixel for UV at a 50-kilometer, 31-mile altitude. Its image format is 1024 times 1024 pixels in its push frames. Its swath coverage is between 60 to 105 kilometers, 37 to 65 miles. Between the 2 camera types, images vary between 0.2 to 0.5 meters per pixel as previously mentioned. A common question arises regarding the focus on the camera types aboard the Lunar Reconnaissance Orbiter and the perceived lack of crystal clear images, despite exceptional resolution, rate, and format. This concern is often attributed to the rapid movement of the lunar surface beneath the orbiting spacecraft. However, the likelihood of not being able to achieve a clear image is proven not to be the case when given the following bits of information. According to a Google search, in order to get a clear, high-resolution photograph of the lunar surface from an altitude of 12 miles, you would need to be traveling at a speed of approximately 3,700 to 3,800 miles per hour. The moon moves at 2,290 miles per hour. That is exactly 1,410 to 1,510 miles per hour, less than the Reconnaissance Orbiter, which orbits around the moon at 3,500 miles per hour. That is faster than the moon, at exactly 1,210 miles per hour. Moreover, according to another Google search, we know that in order to get sharp images, you would need a high shutter speed of, for example, 1/500th of a second or faster. The LRO narrow-angle camera operates at up to 1/2950 of a second. That is exactly 2,450 of a second more than our example. With this in mind, there is absolutely no reason for blurred images. However, some may still argue that while the case for a 12-mile altitude is technically possible, lunar gravity anomalies, mascons, and high mountains can cause you to crash into the surface within days or weeks. But, according to the narrative, this did not happen. As previously stated, they were able to travel at a distance of 12 to 31 miles above the lunar surface. NASA also recommends a shutter speed of 1/125th to 1/250th of a second, but a fast-moving and higher power magnification requires faster shutter speeds to prevent motion blur. And as stated in the previous slide, the LRO narrow-angle camera operates at up to 1/2950 of a second. Therefore, I repeat the question, why are there no crystal-clear, high-resolution images of these alleged Apollo landing lunar sites? With all of this information in mind, I decided to run 2 of the Chandrayaan-2 images through various AI detectors in order to validate authenticity. See the following 4 slides. As previously noted, there are clear discrepancies and contradictions present. If these images were entirely authentic, such inconsistencies in percentage score rates should not exist. These discrepancies reinforce the concerns raised throughout this video, including the presence of AI-generated photos and fabricated live video streams. It is possible that these inconsistencies and blurred images are intentional. Alternatively, the images may simply depict constructed models designed to resemble the lunar surface, photographed from above to simulate a landing site, potentially as part of international collaborations motivated by political interests. This scenario is reminiscent of the depiction of X-Wings and TIE fighters flying over the Death Star in the film Star Wars. I encourage you to consider this critically. Now, I will direct your attention to the 0.5-meter SuperView satellite, as illustrated in the following 5 slides. According to the SuperView website, the 0.5-meter SuperView satellite images, which offer unparalleled detail and accuracy. Spatial resolution refers to the level of detail captured in an image, typically measured in meters per pixel. A 0.5-meter spatial resolution means that each pixel in the image represents an area of 0.5 meters on the ground. This level of detail allows for identifying small objects and features on the Earth's surface with great precision. The clarity of 0.5-meter SuperView satellite images makes them invaluable for a wide range of applications. Overall, the clarity and precision of 0.5-meter SuperView satellite images offer a wealth of opportunities for various industries and sectors. Whether it's for urban planning, environmental monitoring, disaster response, agriculture, or defense, high-resolution satellite imagery plays a crucial role in understanding and managing our world. So, next time you need detailed and accurate satellite images of the Earth's surface, look no further than the impressive 0.5-meter SuperView satellite images. The SuperView satellite travels at 27,000 kilometers. That's 16,777 miles per hour. The SuperView satellite travels at 16,777 miles per hour at an altitude of 500 to 530 kilometers. That's 310 to 350 miles above Earth. The Earth underneath the satellite is spinning at 1,040 miles per hour at the equator, while the North and South poles travel at 0 miles per hour. The spin increases as you move away from Earth's respective poles. And while this is happening, the Earth as a whole itself is traveling through space at 67,000 miles per hour. This movement, however, does not affect the SuperView satellite camera with its 0.5 resolution capabilities, as we have seen previously. According to the narrative, the LRO travels at 3,600 miles per hour. That is 13,177 miles per hour, less than the SuperView satellite. And while the LRO was doing that, it was orbiting the moon at an altitude of 12 to 31 miles above the lunar surface, taking pictures of various Apollo landing module sites. comparing the SuperView satellite and the LRO together with their relative speeds and altitudes in conjunction with their orbital geographies. Both of their high-resolution 0.5-meter cameras should provide us with crystal-clear images, but they do not. The SuperView satellite operates at higher speeds and altitudes than the Lunar Reconnaissance Orbiter LRO, which travels more slowly at a lower altitude. Typically, increased speed and altitude result in greater image blurring. However, the SuperView satellite produces clear images despite these conditions. Conversely, the LRO, which should yield clearer images due to its slower speed and lower altitude, does not. This inconsistency suggests the possibility of intentional image blurring or manipulation to obscure certain details, to conceal its miniature toy-like realities. These discrepancies are evident in the Chandrayaan-2 images and other collaborative photographs from various countries depicting the Apollo landing module sites. You may believe that my references to ping-pong tables and miniature toy models are unfounded. However, if that is the case, I invite you to address the discrepancies and contradictions presented in this video. I am aware that a common response is to question the reliability of AI detector applications, given that their results are not always definitive. This perspective, however, misinterprets the operational principles of these tools. As previously discussed, an AI application does not need to be perfectly accurate, but it should demonstrate consistency in its percentage scores. For instance, if an image receives a 67% score from one application, it should yield similar results when analyzed by 3 to 5 other applications. In this regard, the applications have not failed. Furthermore, as explained earlier in this video, every time you see a percentage score, like in some cases 47% and so forth, that means the image or video was edited by a human, as in 47% human, while the other 53% score means that the final product is artificial. You can look this fact up for yourself. Therefore, there should be no discrepancies, contradictions, or blurred images. Based on this analysis, I conclude that the so-called latest mission was another hoax perpetrated on the public using taxpayer funds. Naturally, many of you are probably thinking, what about all the launches, re-entries, and splashdowns that we saw in person or on livestream? How can they possibly fake that? The answer to that question is that they didn't. Ironically enough, flat earthers asked the very same question, but from a different perspective. Well-informed flat earthers do not deny the launching of rockets or their splashdowns. Those who do are simply misinformed. The question should actually be one of application. In their attempt to show people that rockets curved due to their inability to penetrate the firmament dome of Earth, flat earthers usually accompany their rebuttals with pictures or memes depicting rockets performing an arch or a curve. See the following slide. Flat Earth proponents also cite that this is precisely the reason why we never see a rocket go into space. NASA and other space agencies often cut to a CGI animation of what is happening as the rocket falls out of view to the observer. After the animation and broadcast is completed, we return to our regularly scheduled programming. It is only after 2, 3, or 5 days and even weeks of non-observable evidence that we are suddenly given photos and video feeds. To the flat earther, this is suspicious activity. However, according to mainstream science, rockets curve because if a rocket just flew straight up, then it would fall right back down to Earth when it ran out of fuel. Rockets have to tilt to the side as they travel into the sky in order to obtain a circular path of motion around the Earth. This steering technique is known as a gravity turn, which uses Earth's gravity to help conserve rocket fuel and minimize stress and strain on the spacecraft. This works by rotating the spacecraft until its heavier side is facing down to help curve its flight into orbit. Moreover, the reason why rockets are launched vertically instead of simply launching sideways like a plane is that by starting out going straight up, they get past the majority of the atmosphere quickly. So, on most launches, the spacecraft gets just high enough to get above what is called max Q, which is rocket scientists' talk for the point of maximum aerodynamic resistance on the rocket. Exactly where this occurs is a function of both the density of the atmosphere and the speed of the rocket. For the space shuttle, it occurred at about 35,000 feet. Most rockets launch to the east, because the Earth is already rotating east, and therefore, when it is still on the launch pad, and you are already traveling at 1,000 miles per hour in an eastern direction. Depending on how close to the equator you are, closer to the equator means a higher resting velocity. This is the answer as to why we never see a rocket go straight up into space. This principle of aerodynamics also holds true for re-entry until splashdown. See the following picture and GIF for illustrative purposes. Proponents of the flat Earth model often respond to such arguments by citing NASA documents that reference a non-rotating, flat, stationary Earth in the context of calculations involving linearization. Globe Earthers object to this. Globe Earthers insist that in order to linearize a nonlinear flight model for the purpose of simplification, you have to assume those criteria, otherwise it would no longer be linear. Linear algebra is used to make approximations of nonlinear models. If the mass changes, the calculations are no longer linear. If the vector of gravity changes via a spherical Earth, it wouldn't be linear. A flat plane and constant mass are demands to linearize the math. These documents are articulating the process used to linearize the model for quicker approximations. Those that are using such documents as a justification for a flat Earth have no flipping idea what they are reading or understand linear algebra. If flight happened with things of constant mass on a flat plane, then the linear model would be the only one that existed. There wouldn't be papers about the process of linearization. The objection is correct, but the objection does not account for linear independence, or two vectors having two different dimensions. If two vectors point in different directions, even if they are not very different in direction, then the two vectors are said to be linearly independent. If vectors point in the same direction, then you can multiply vector by a constant, scalar value, and get vector, and vice versa to get from the two. If the two vectors point in different directions, it then becomes impossible to make one out of the other, because multiplying a vector by a scalar will never change the direction of the vector. It will only change the magnitude. This concept generalizes to families of more than two vectors. Three vectors are said to be linearly independent if there is no way to construct one vector by combining scaled versions of the other two. The same definition applies to families of four or more vectors by applying the same rules. Question: can you add two vectors representing physical quantities having different dimensions? Solution: two quantities cannot be added or subtracted if they have different dimensions, be it a vector or a scalar quantity. But they can be multiplied or divided, or only multiplied in the case of vectors. Now, if the magnitude be changed, then consider the vector space. See the following statement in the next slide, and its answer demonstrating a flat infinite plane, a flat Earth. Moreover, Newton's formula for gravity does not interfere with flat Earth computations when utilizing Gauss's law and pillbox with alleged gravitational forces. For in-depth information on an infinite flat Earth, its physics, Gauss's law, and pillbox, see the two video and website links in the description below. Previously, we learned about launches, re-entries, and splashdowns. But we did not give any attention as to why there are blackouts upon entry and re-entry into and from space while traveling through Earth's atmosphere. As noted earlier, this raises a question of doubt among flat Earth proponents. According to the narrative, a communicative blackout was a planned 6-minute event. Some reports indicate up to 13 minutes, caused by the Orion capsule entering Earth's atmosphere at nearly 24,000 miles per hour. Intense heat from re-entry creates a layer of ionized plasma around the spacecraft, which disrupts radio signals and creates a temporary, expected communication gap. This gap causes over-the-air television blackouts. A person would literally have to personally film a spaceship re-entering the Earth's atmosphere during the superheated, ionized plasma phase. The plasma forms during the peak of re-entry, where temperatures exceed 18,000 degrees Fahrenheit. Some reports indicate up to 24,000 degrees Fahrenheit. And while it is possible to personally film a spaceship re-entering Earth's atmosphere during the superheated, ionized phase, it requires specific timing, location, and equipment, as the plasma phase is rare, brief, and incredibly bright. Your timing and location must be in the right place and at the right time. A person can track a re-entry manually or by using a high-tracking telescope/camera mount to keep in frame. What you will capture is a bright central body, rather than the detailed shape of the ship. See the following slide. Some flat Earth proponents would argue that the preceding picture is a complete fabrication. They would most likely claim that the photo was taken from eye level, as seen from the ISS from an Earth reentry point. According to the narrative, NASA officially considers Earth's atmospheric entry point for the Artemis missions to be 400,000 feet, 76 miles, or 122 kilometers above the Earth's surface. The ISS is said to currently orbit the Earth between 419 to 429 kilometers, 260 to 266 miles above the Earth. You cannot take a photo of an object at eye level with a 184 to 190 mile difference. However, this is not the case. You can still take a picture that would appear to be at eye level if you are thousands of miles away. At that distance, the angle flattens out, creating an optical illusion of being eye to eye. However, taking a true eye-level portrait with a 184 to 190 mile drop in altitude is physically impossible. I believe that the linear trajectories and curved paths observed in rocket launches are most likely influenced by the shape of the firmament, or dome, which I consider to be positioned above a non-rotating, stationary Earth. While the flat Earth remains motionless, all celestial objects above, whether circular or otherwise, whether fixed stars moving within their dome boundaries or wandering stars, require precise calculations for any human attempt to approach them, such as missions to the moon. Although I do not question the technical capability to perform these calculations, I reject the mainstream consensus regarding a spherical Earth. They know it's flat, but they will never admit it. Instead, they continually choose to promote a specific cosmological narrative. This narrative, according to some, promotes a worldview rooted in atheistic evolution and diminishes individual significance. In contrast, each person possesses inherent worth, spiritual potential, and independence, having been created by an eternal being for a specific purpose. NASA and other space agencies consistently present the Earth as a sphere, often employing fisheye lenses that distort the horizon to appear curved. See the following 2 slides. Proponents of the flat Earth perspective argue that, in reality, the Earth is flat, while some, like myself, would argue that it is a flat, infinite circular plane where the horizon always rises to eye level and the edges never converge. When fisheye lenses are not used, space agencies provide us with AI-generated images and altered video feeds to reinforce the prevailing cosmological narrative. For further information regarding cameras, lenses, and video equipment utilized by NASA, please refer to the website link provided in the description below. Epilogue. The following slide is presented for illustrative purposes only. Thank you for watching this video through its completion.